Hello, Mastery Algebra 1. I'm Mr. White. This is 8-1, adding and subtracting polynomials. So far we have worked with linear first-degree polynomials. We've solved linear equations and inequalities. We've graphed linear equations and inequalities, and then we also started looking at two variables. Okay, now what we're going to do is we're going to look at higher-ordered polynomials and their characteristics. But first we have to look at a couple definitions and then proceed from there. First definition we need to look at is a monomial. The term mono means one. So it's a real number, a variable, or a product of numbers and variables that are put together. For instance, we have a real number. We could say 6. We could say x. We could actually do a product with xy. We could actually say 6x squared y. Those are all monomials. Okay? The degree of the monomial is the sum of those exponents of its variables. Okay? So when we're looking at the degree, what we're going to concentrate on is not necessarily the coefficient or the number, but we're going to look at the variables like x. X is raised to the first, so that's going to help us find the degree. X is to the first and y is to the first. That is going to help us with the degree. Or in this last case, we're going to look at the squared on the x and the 1 on the y. Okay, so finding the degree of a monomial, okay, if we look at a, 5x, we know that the x is raised to the first power. So what this is going to tell us is the degree is 1. So 5x to the 1 is really, the exponent is 1. So its degree is 1. Okay. For b, as soon as we bring in more variables, okay, we're going to look at the x and the y. We know that the degree on x is 3. We're going to add that to the degree on y, which is 2, and that's going to give us a total degree of the monomial of 5. Okay. So what we have to do is it's the sum of 3 plus 2. And the last one, c. 4 does not have a variable. So let's pretend if this were 4x to the 0. Remember, anything to the 0 power is 1. So it's still 4. And therefore, the degree is 0. So 4x to the 0 is really 4, which the degree is equal to 0. Okay. So a, the degree was 1. B, the degree was 5. And c, the degree was 0. All right, try these for size. Number 1, on the side, if you write it down, we have 8xy. What's the degree? 5, 4, 3, 2, 1. Yes, we have the degree of 1 and 1 on the y. So the exponents were 1 and 1. So we're going to add those two, and the degree is 2. Second one, if we have negative 7y to the 4th x, the degree, we'll take 4 on the y plus the 1 on the x, so the degree is 5. And the last one more, if we have 11, you should know that degree is just like 11x to the 0. Okay, so the degree is 0. Okay, we can add or subtract monomials by adding or subtracting like terms. Okay, remember though, that the like terms must have the same variables with the same exponents. For example, a, if we're going to add the sum or difference. In order to add these two monomials together, okay, we first look at the variables. This is an x squared and this is an x squared. Since they both have the same variables raised to the same power, we simply add the coefficients together, 3 plus 5, and then keep the x squared. So this is going to give us 8x squared. Okay. On b, notice what we have. We have an x cubed y, and then we are subtracting an x cubed y. Since both of those have the same variables, we're going to take 4 minus this 1, but then just keep the same variables. We are not multiplying, we're not adding variables or anything. We're just adding the coefficients. So 4 minus 1 gives us 3 x cubed y. What about this one? What about negative 6x to the 4th plus 11x to the 4th? Notice, both variables are x to the 4th, so we can go negative 6 plus 11 is going to give us 5, and then we just drop down or keep the same variable. So it should be 5x to the 4th. Okay, one more. 2x squared y to the 4th minus 7x squared y to the 4th. Hey, what we should get? 2 minus 7 is going to give us negative 5, and then we keep the x squared y to the 4th. How about this one? If we had 3x cubed minus 6x squared plus 2x cubed. Okay, what we're going to do is we're going to look at, what do we have? Well, we have an x cubed, we have an x squared, and we have an x cubed. Because these two outer ones have the same variable that's cubed, we're going to add those. So 3 plus 2 is going to give us 5x cubed, and then this minus 6x squared stays. So now our answer becomes 5x cubed minus 6x squared. You cannot combine those. They are not like terms. Another definition. Polynomial. A polynomial is a monomial, or also it's a sum of a bunch of monomials. Okay, so for instance, we have 3x to the 4th plus 5x squared minus 7x plus 1. What we can do is we could go through each part, and we have to figure out, well, what are the degrees of each monomial, and then what is the degree of the actual whole polynomial? So the first one we have to look at is, and if you see, the degree of each monomial is 4. So this one is 4. We know that this one is 2. We know that this one is 1. And then that this one is 0. If you notice, it goes from 4, 2, 1, and 0. This is actually also in standard form. We usually write polynomials from where it goes from highest to lowest degree. And then what we can do is name the degree of the polynomial based off the highest degree of a monomial. So once it's in standard form, this means that the degrees of its monomials decrease from left to right. The degree of the polynomial is the same as the monomial with the highest term. So since the degree of the highest term is 4, we know the degree of the polynomial is 4. So it's a 4th degree polynomial. Next page. All right, we can classify each polynomial based on their degree or by the number of terms that it contains. These are 5 plus maybe one more that you need to know. So for instance, we had the first one, which was 6. Or again, if you remember, it's 6x0. So the degree is 0. We call that a constant. Okay? There's only one term, and one terms are monomials. Okay? If we have 5x plus 9, we've dealt with this. We know that x is raised to the first, which is our linear. So it's a first degree. We call it linear, just like our linear lines. It has two terms. It has a monomial here and a monomial here that we're adding. Okay, we call two terms, just like a bicycle, we call it a binomial. Now if we add another one, we go 4x squared plus 7x plus 3. We now have a second degree, because the 2 is the highest. We call those quadratics. Okay, it has 3 terms, and 3 terms are trinomials. Okay, these two right here, binomial and trinomial, are the most common that you'll see throughout the polynomial terms. Okay, if we have 2x cubed, now we have a 3, so it is a third degree. We call that cubic. That happened to have one term, so that's still a monomial. And if we go 4th degree, we have 8x to the 4th minus 2x cubed plus 3x. We have 4th degree. It is, they say 4th degree, but we also call it a quartic. So we'll call it quartic. It has 3 terms, so it's a trinomial. And then one more we need to kind of look at is if I had 5x to the 5th power minus 2x plus 1. This degree has a 5 and a 1 and a 0, so it's a 5th degree. We call this quintic. This happened to have 3 terms, so it's also a trinomial. So you will need to know how to name it by degree and also classify it by the number of terms. For instance, we're going to write each one in standard form, and then what is the name of the polynomial based on its degree and number of terms. So if we look at A, okay, first we have an x to the first, we have an x to the second. Those are not like terms. So we need to rearrange this from highest to lowest. So we know that the x squared goes first, so we'll write 4x squared plus 3x. So now we have it in standard form. Okay, what we need to do is we need to now call it based on its degree. So we know the degree is 2. We call second degree, if you remember from above, we call those quadratics. So this is a quadratic, and it has 2 terms. 2 terms is binomial. So it's a quadratic binomial. B, hit pause. Go ahead, try it. I'll see you back in 30 seconds. Go. All right, welcome back. If you notice, I rearranged them from highest to lowest. So starting with the 5x to the 3, then both of the next ones are x's, so I just put plus 4x plus 7x minus 1. We can combine the ones in the middle. They have the same degree, so they are like terms. So when we add 4 plus 7, we're going to get 11, and then remember, we keep just the same degree, so it's x to the first, and then minus 1. So our answer was 5x cubed plus 11x minus 1. Okay, now we had to call this, so hopefully you said it is a third degree, so degree is 3. We call third degrees cubics, so we're going to say it's a cubic, and it has 3 terms, so this is a cubic trinomial. All right, problem 5, subtracting polynomials. Okay, we need to write this simpler form. Again, keep it in standard form from highest degree to lowest degree. And then we can try and name it if we need to. Okay. The first time what we're going to do is from highest to lowest degree. So we have x cubed. We have a minus 3x squared plus 5x. If you notice, degree is a third degree. Then it goes 2. Then it goes 1. We are missing that 0. Sometimes it helps to plus. So if it's missing the 0, we can just put in like a placeholder and call this plus 0. Okay. Now what we're going to do is we're going to subtract the other polynomial. If we remember back from chapter 1, we're going to distribute the opposite or look at it as opposite. So the opposite of 7x cubed becomes minus 7x cubed. What we're going to do is we're going to place that underneath the same degree. So we're going to write minus 7x cubed underneath the x cubed. Then we're going to take the opposite of a positive 5x squared. So we're going to go minus 5x squared. And then we have to look at, do we have x to the first? When we take the opposite of negative 12, we have positive 12. So the positive 12 goes here. So we do not have anything that's x to the first. Okay. Once they're all lined up, simply add or subtract based on what we have. So we have a 1 minus 7 gives us negative 6. Then keep the degree. Minus 3 minus 8 gives us negative 8 squared. We bring down the 5x. And then we have plus 12. So our polynomial is negative 6x cubed minus 8x squared plus 5x plus 12. Okay, degree, just to double check. Degree of the polynomial, the highest degree is a 3. So we know it's third degree. We can call this a cubic, and it has 4 terms. Well, remember, based on the terms, we had a monomial, binomial, trinomial. So what's 4? We just simply call those polynomials. So this really is just a cubic polynomial. All right, let's see if you got it. Hit pause. Try number 5. Be sure to show your work. Be sure to write it in standard form. And then let's see if you can try the degree and the name. Go. All right, welcome back. By putting it in standard form, we should have gotten negative 4m cubed minus 4m squared minus 2m plus 21. Big key right here. Notice this goes from third degree to a 1 degree in the first polynomial. So I had to put a placeholder here at 0m squared. Doesn't mean we have any m squared. It just helps us line up our like terms. Then we had minus m. So when we add down, negative 4 plus 0 is negative 4m cubed. 0 minus 4 is negative 4m squared. Negative 1m minus 1m gives us negative 2m. And then the plus 21. Okay, degree, hopefully you wrote down it's a third degree. Okay, we call third degrees, if you remember, cubics. And this doesn't have 1 term, 2 term, 3 terms, it has 4. So we'll just call it a polynomial. Good job. Our next page, practice. Adding and subtracting polynomials. And then we want to put them all in standard form. So let's do a couple together, and then we'll turn you loose. Number 1, if you notice, we have 4x squared plus 8x minus 8. That is already in standard form, decreasing order, not miss anything. We're going to add, bring down the 3x squared. We're going to put the plus x and the minus 8. Draw our line, add straight down. You get 7x squared plus 9x minus 16. and that's in standard form. Okay, just checking. It is a quadratic trinomial, second degree. Number 2, we have x squared minus 4x plus 4. Now we're going to subtract the next polynomial. So the opposite of 3x squared gives us negative 3x squared. The opposite of x gives us minus x, and the opposite of negative 8 gives us positive 8. If we draw our line, 1 minus 3 gives us negative 2x squared. Negative 4, negative 1 make negative 5x plus 12. Good job. Okay, let's skip all the way down to 14. All right, we have, if I look at this polynomial, 2x cubed looks to be the biggest. So we have 2x cubed minus 5x squared minus 6x. So 3, 2, 1. We do not have a constant, so I can put just a plus 0 just to help out. We're going to subtract a 4x squared. So I'm going to write minus 4x squared underneath the x squared. I'm going to subtract a positive x, so we're going to write that underneath the 6x. And then we're going to subtract a negative 7, so that changes to positive 7. If we draw a line, now if we add combine like terms, we're going to get 2x cubed minus 9x squared minus 7x plus 7. Again, just double checking. You should notice this is a third degree, and we would call it a cubic polynomial. All right, one more, 15. Notice if you look at the first polynomial, it's not in standard form. So let's just rearrange it. We know the highest degree is 2. So we're going to write minus x squared first. We have a plus 4x. And then we have a minus 2. If we add the next polynomial, notice now we have an 8x cubed. So we're going to put that just in front of the x squared. So we have a minus 8x cubed. We have an x squared, so we're going to add that to the x squared. And then we have just a plus 3. So we do not have an x, so I can put in a placeholder. But we do have a plus 3. Draw my line. Now our polynomial becomes negative 8x cubed minus 7x squared plus 4x plus 1. That is a cubic third degree polynomial. All right, congratulations. This concludes 8-1. Be sure to finish the remaining. Please show your work. Make sure you put them in standard form, and then check with yourself the degree, maybe trying to name it by yourself, okay? And then check your answers at the end of this video. Have a wonderful day, and remember, do your best, forget the rest. Bye for now.